Thanks for being back here on the program. You remember Isha, right?
Yes, I do. And
Yeah.
Wonderful to join you.
Yeah, I know we're doing quite a bit of interviews over the coming weeks, and I just wanted to say I'm really excited to see where your research has gone since we last chatted about Oumuamua last year.
Thank you.
Well, there was Oumuamua, and then there was the investigation you did somewhere in the South Pacific. And are you doing something new? Because there's lots of questions we want to talk about. So you have a little presentation, and then we'll talk, right?
Yeah, I mean, I can present for a few minutes, or you can just ask questions. It's up to you. Whatever.
Well, why don't you do a little presentation so we know where you're at? But first, let me introduce Avi Loeb, as I think you're still the head of the Harvard Astronomy Department, or you former head?
No, I completed my term. I'm the director of the Institute for Theory and Computation at Harvard.
Right. And he's also the head of the Galileo Project, which is amassing lots of information about potential UFO, UAP, directions that's being made there. And I'm going to ask you about that. And also his first book, Extraterrestrial, about Oumuamua, was quite a hit in the market, despite what his astronomer colleagues had thought about it, because what Avi pointed out is the open-mindedness that needs to be made in the sciences instead of people being confined to what they think is true. And Avi, you made a great, impact on other people, saying maybe they should open their minds to what else is possible. So I'm interested in what you're working on now. Do a little presentation, and then we'll talk. Okay.
Okay. So maybe I'll share my screen. Let's see if it works.
Yes. Yes, you know how to do that. You go down to present. You see under present, under StreamYard down at the bottom. Is that?
Yes. The only issue is that it doesn't allow me to share the entire screen.
What about just share slides? Could you have a slideshow? Do you have a?
Yeah, I do.
Avi, you should be able to click share screen, entire screen, and then you click entire screen, and then you click share. You got to click the actual window.
Unfortunately, that was not a possibility. Let me just see.
Unless if you have a Mac and you haven't changed your settings on your Mac for it, yeah.
It is a Mac, yes.
Yeah, that would be a setting thing. We'd have to go to your privacy settings and allow Chrome sharing.
Oh, well, why don't we just talk through what you were going to present? What were you going to present in the slideshow?
Okay, well, I mean, I can just for a few minutes tell you the latest. And
yes.
As you mentioned, in 2017, the first object from outside the solar system was identified by astronomers. It was given the name Oumuamua, and it was the size of a football field and had very unusual properties. I'm just trying to see if it will allow me to share the screen. No, it's still problematic. And so, at any event, this object was unusual in the sense that its brightness changed by a factor of 10 as it was tumbling every 8 hours, and its shape was most likely flat. And moreover, it was pushed away from the sun by some mysterious force. It was unclear what is pushing it because there was no gas or dust around it. And a few years later, we discovered another object, a meteor, roughly 0.5 meter in size, that collided with Earth and also came from outside the solar system. We know that because it was moving too fast to be bound by gravity to the sun. And this one was weird because it was moving faster than 95% of the stars near the sun. And moreover, it had material strength tougher than iron meteorites. And I decided to lead an expedition to the Pacific Ocean. We went there in June 2023, a year ago, to search for materials from this meteor. And we just published the results in a scientific paper showing that we found material that has a chemical composition different from what you find in the solar system usually. So it's quite likely that this object came from outside the solar system. And what we hope to do in a year from now is search for bigger pieces of this object so we can tell if it was artificial or natural in origin, whether it was manufactured by another civilization. For Oumuamua, I suggested that it's being pushed by reflecting sunlight. And for that, the object had to be very thin, like a membrane. And nature doesn't make such thin objects. I suggested maybe it's a surface layer that was torn apart from a bigger object, or perhaps a broken piece of a megastructure constructed by another civilization. And now with the Galileo project, we built a new observatory that is currently monitoring the sky 24/7 in the infrared, optical, radio, and audio. And the goal is to figure out if there are any unusual objects in the sky, because the US government, the Director of National Intelligence, suggested that military personnel are seeing things they don't understand. And so we are about to submit a paper that reports the first results from the first observatory at Harvard University. We analyzed the data with machine learning software, and we describe the findings so far. But we are planning to continue to look at the sky in the future, look for unusual objects. We are building 2 additional observatories in other locations. So altogether, within a year, we'll have 3 observatories monitoring the sky. And there will be a congressional hearing in a month discussing some possible information that the government might have about those unusual objects. So stay tuned.
Yeah. No, there's a lot of interesting things you just brought up. First of all, going back to the object you found in the ocean, how do you know the chemical composition is from another solar system, especially since we haven't explored our solar system completely?
Okay, by the way, I was able now to share for some reason.
Okay, great.
So let me just show a few slides describing what I mentioned before.
Perfect.
Well, this is just a beautiful image of the stars in the Milky Way. There are hundreds of billions of them, and to think that we are alone is really arrogant. That we are unique and special. This is an artist's illustration of Oumuamua that I mentioned, and potentially it could have been a thin membrane rather than a rock of some unusual shape, because astronomers decided that it's flat. And Enrico Fermi asked this question of where is everybody, to which my answer is we need to search. We can't just expect them to come to us. We need to look for them. And the next Copernican revolution would be that we will find them. And here you see an actual image of the Tesla Roadster car that was launched by Elon Musk in 2018. And, if it were to collide with Earth, many of my colleagues would argue it's a rock of an unusual composition that we've never seen before. But I would argue, let's be open-minded and consider a technological origin. Maybe there are interstellar cars, and Elon Musk was not the most accomplished space entrepreneur since the Big Bang. And of course, you need to collect evidence, and that costs money and effort, and that's what I'm trying to do, because new scientific knowledge does not fall into our lap. I mentioned already the Oumuamua that was discovered in 2017, and the meteor that collided with Earth a decade ago, 2014. And these are the reports from the Director of National Intelligence to the US Congress. This is an artist's illustration of our observatory at Harvard to look for those unidentified objects. And as I mentioned, I went to the expedition. The US government confirmed that this was an interstellar meteor. This is the team that I led on the ship. We hope to go again in a year. These are some photos from that expedition. And there will be a Netflix documentary at the end of 2025 coming out that includes footage from that expedition. We found these molten droplets that are less than a millimeter in size, and about 10% of them were of unusual composition, up to 1,000 times more abundance of some elements like uranium, lanthanum, beryllium, relative to solar system materials. We are planning the next expedition, and hopefully we'll find bigger pieces of the meteor to tell us what it was. And this is the Rubin Observatory that will start operation in 2025. We'll use a camera that has 3.2 billion pixels. It's roughly the size of a person. And it will hopefully find many more interstellar objects like Oumuamua once every few months or so. So stay tuned. That's what I wanted to show in terms of my slides.
How do you know that the chemical makeup is something from outside the solar system if we haven't explored the solar system completely?
Oh, because we know what the material that made the solar system had a uniform composition. I mean, we see the same composition in the sun and in all the other bodies left over from the formation process of the sun. And so we know, for example, the composition of the crust of the Earth, the moon, the asteroids, Mars, and obviously the sun. And so what we found is an abundance of some elements that is very different than any of these objects. Okay, so we can tell the difference.
So is your hypothesis that different stars have different sort of chemical outputs that create different elements in different solar systems? Is that the idea?
Well, we definitely know that to be the case because the heavy elements originate primarily from exploding stars that are very massive, and once they consume their nuclear fuel, they explode in events called supernovae. We see those supernovae, and really, it really depends on how close you are to a supernova as to how much enrichment the star gets. And moreover, you can imagine environments that even if they started with similar chemical composition to that of the solar system, there were processes that changed it. For example, if you destroy a planet when it's coming very close to the host star, some elements would, if you melt the rock, let's say of a rocky planet like the Earth, when it comes close to a dwarf star, the most common star, then some chemical elements will sink to the core of the planet and others will stay on the surface. And then you can get an enhanced abundance of some elements, those that we see relative to others. And so you can imagine situations where the things that would be ejected to interstellar space would originate from environments very different than the ones in the solar system, because the sun is not a typical star. The sun is 10 times more massive than the most abundant stars, dwarf stars.
Wait, our sun is 10 times more massive than dwarf stars, you're saying? Than
the typical star, yeah. So the nearest star to the sun is 12% of the mass of the sun. That's called Proxima Centauri.
Yeah.
The sun is not a typical star. So you might ask, why are we residing next to a star that is not the most common star? And the other thing to keep in mind is dwarf stars live up to 1,000 times longer than the sun. So you would ask, why aren't we next to a dwarf star in our future? Because there is much more time left for those nuclear reactors to keep burning compared to the sun. The sun is roughly at the middle of its lifespan. So we happen to be born next to a star relatively early. If you would allow us to exist next to dwarf stars, we would be we would find ourselves sometime in the future. I mean, if you select a random day in your life, it would most likely be at the middle of your life, not the first day of your life or the last day. And just because there are many more days near the middle of your life. So then one possible explanation is that the dwarf stars are not hospitable for life as we know it, because they have flares, and they basically, those flares sterilize the planets that are in the so-called habitable zone, in the region close to those nuclear furnaces that could, in principle, have liquid water. But because of the flares, those planets lose their atmosphere. The atmosphere gets stripped by either the wind coming from the star, because they're closer to the furnace, because the furnace is actually fainter. The dwarf stars are fainter. So in order to have liquid water, you need to be closer to the star, and then you are more vulnerable to losing the atmosphere. And the other, obviously flares could also do that. So altogether, it may well be that stars like the sun are really the only incubators for life as we know it. And that's why we find ourselves at a typical time in the middle of the life of a star like the sun.
Do you think that possibly the whole collision of the Sagittarius galaxy with the Milky Way, do you know about that theory? Is that?
Oh, yeah, I wrote, if you are referring to Andromeda or Sagittarius, in both cases, I actually did I did the most extensive modeling of those systems, the first one.
So could our sun be part of that other galaxy? Because wait, one more thing, the ecliptic of our solar plane is at a strange angle to the ecliptic of the Milky Way, why would that be? So anyway, what do you?
Well, it would be the case because it has nothing to do with each other. I mean, the solar system formed out of a cloud of gas that was rotating in some random direction relative to the disk of the Milky Way. I mean, it didn't have to. It was spun up by processes that were local and had nothing to do with the way that the Milky Way disk is oriented.
Okay, but do you think,
So we are, when you look at the sky, you from the right locations on Earth, you see the Andromeda galaxy. It's a sister galaxy, very similar in mass to the Milky Way galaxy, that is currently approaching us at 110 kilometers per second. So we know that it's on a collision course with the Milky Way, and once the two galaxies collide in a few billion years, the sun will still be around, and the stars of the two galaxies will mix together. Right now, the Milky Way is a disk of stars. So all the stars formed out of gas that they formed in a disk, similar to the planets that formed in a disk around the sun, but the two disks had nothing to do with each other.
Okay.
They were they were oriented at random orientation.
Right.
But when the Milky Way galaxy collides with the disk of Andromeda, the two disks will get mixed, and you will end up with something that looks like an elliptical galaxy. It looks like a football-shaped galaxy. And instead of the stars appearing in the sky like a strip, the way it is now, and that's why we call it the Milky Way, the stars will be scattered in the sky. And in fact, the sun could be, in principle, stolen from the Milky Way during the merger process. And we could see the Milky Way from a distance.
What do you think of the Hubble Telescope finding really well-formed galaxies way out where they didn't expect anything to be as developed as what we found? That changes the whole cosmology, right?
So actually, when I arrived at Harvard about 30 years ago, I pioneered this theoretical study of the first stars and galaxies. That was my first big contribution to astrophysics, and now it's a very popular field of research. I was actually on the first advisory committee that designed the Webb telescope that we now use to observe those galaxies. Right. And I wrote a textbook about 12 years ago, The First Galaxies in the Universe. And that textbook basically summarizes what we theoretically expected. And I was always saying that if the Webb telescope finds something different than we expected, I would be very happy, because it would teach us something new. I mean, that's science is a learning experience. Exactly. And indeed, it taught us something new, that the early generation of galaxies are quite bright, brighter than we expected. But that could be explained, for example, if the first generation of stars were brighter than the stars today. And that's actually a prediction that theorists like myself made early on. So we are not yet fully clear about what the reason is for the first galaxies being brighter, but I wouldn't be surprised if it's simply because the first generation of stars were more massive than present-day stars, so they were much brighter, and that accounts for the brightening of those galaxies. But it doesn't violate the standard cosmological model.
Oh, okay. I wanted to get that straight, because some people said, the universe must be much older than we had expected, but you're saying it's just the brightness of that.
I mean, the reason the universe cannot be much older is because we have data from the early universe, even before the first stars formed. Then this is the cosmic microwave background, the radiation left over from the Big Bang.
Right.
And we can use it to, it has features, it has temperature fluctuations in it that can be used to map cosmic history. And from that alone, even without anything, to do with the stars and galaxies, we can tell the age of the universe. Everything falls into place, to within 10%. People are arguing about 10% right now. Yeah. There is the so-called Hubble tension, less than 10%. But I'm saying to within 10%, we know the age of the universe pretty well. And it's the one that is fully consistent with those early galaxies.
Right. Okay. Let's talk about Oumuamua, which the actual Oumuamua, sorry, but the translation means first scout in Hawaiian, right?
That's right. First. Yes.
And it's interesting. In 2017, it was that year that the Pentagon and New York Times published these videos of UFOs as if Oumuamua was announcing something. I mean, just mythologically speaking, right? So
yeah, the coincidence is interesting because Oumuamua showed up on October 19th, 2017, and then in December that year there was the report in the New York Times about the government program. I was wondering if there's any causal relation between these two things. And in fact, I wrote a draft of a paper saying, in principle, an object like Oumuamua could be a mothership that, is releasing probes that would arrive to Earth, weeks or months later. And so that should be a possibility that we consider, that when there is a big interstellar object, if it's not a rock, if it's not natural, if it's artificial and it's functional, it could potentially lead to us noticing something on Earth. And now we don't know, we didn't have enough data. And my hope is that when we continue observing, monitoring the sky with the Rubin Observatory starting next year, that we would see more objects like Oumuamua, so we can get to the bottom of it. Because now, I'm very intrigued. So we developed a computer program to find out the interstellar objects in the data pipeline from Rubin Observatory. And we also, I just submitted yesterday a proposal to the Webb telescope to use the Webb telescope to look at objects that are interstellar, because the Webb telescope will allow us to measure the heat emitted from those objects and figure out their size, their surface temperature, pinpoint their location very precisely, and check if they have any propulsion. So I'm really optimistic that once we start searching for these objects and using the Webb telescope and the best telescopes on Earth, we will learn much more. And, having more data, more evidence, to me, is a blessing, a great blessing. The only people that object to that are people that want to maintain their past prejudice. That these are people that claim that everything in the sky must be rocks. And some of them are my friends,
Well, was it Max Planck that says science moves one funeral at a time, moves forward,
Well, I would not wish that to them, but one of them told me Oumuamua is so weird, I wish it never existed. And to me that is the opposite approach that a scientist should take, because one should say, if you are curious, you should say, Oumuamua is so weird, I want to learn more about it. It's really intriguing. Maybe nature is trying to tell me something I don't know yet.
Right. That was Richard Feynman's thing. When you find something new, it's not, you don't discount it. You say, isn't that interesting? And then you pursue that. So getting back to what the government's all about, I'm sure you know about this book. Sorry, it's backwards.
Yeah, I know the book and I know the author.
Right. Well. And he claims that you don't have to, you're looking out there, but the government has crashed retrieval. It has started reverse engineering. So I guess you haven't had access to those programs and haven't seen it because you're still looking out there. Would you?
Well, I would be happy if the government saves me time. If they are willing to share the data they have. if it's not a matter of national security, if one can tell from the data that it's not the Russians, the Chinese, North Korea, or any other adversarial nation, they have the duty to share it with scientists like myself, because their day job is national security. My day job is what lies outside the solar system.
Right.
And, it's information that could guide us into the future, because anything that comes from another star, might be far more advanced than what we have. And, it could reveal technologies of our future. And it's better for scientists to figure out what these things are. And I very much hope that they will, at some point, if they have something, will share it with me. At the moment, they haven't. But I should also say that there is a plan for a hearing in the U.S. Congress in about a month.
November 13th, yes.
Yeah,
But
so stay tuned, because there might be some interesting details revealed there.
well, this Elizondo says yes, there's craft. David Grush says yes, there's craft.
Well, okay. So
Right.
I should add a caveat here, because I had an hour-long conversation with David Grush over Zoom, and I asked him to let me know of anything that is not already in the public domain. I'm a scientist, so I'm guided by evidence. I'm not guided by hearsay. You can't base a scientific analysis on a rumor. That's not the way it works. I mean, the same way that FIFA, the soccer organization, operates, they don't go around ask the players whether there was a goal. They look at their cameras and decide. The referee decides based on.
It's not necessarily rumor, because these are people in the intelligence
No.
field.
But,
right?
okay, so here is the point. In difference from the legal system, where you can put a person in jail based on eyewitness testimonies, in science, it's all about instruments, just like FIFA, as I mentioned. So I cannot rely on what Elizondo tells me. I want him to show me the data. It's just like, show me the money. For a scientist.
What did Grush say in your conversation?
Well, so I asked him to show me anything that I don't know already from before the time of his testimony. And he said that he cannot do that because he would be legally held responsible for any such release and might be put in jail. And I said, why don't you become the Snowden of unidentified aerial phenomena? And he's not willing to do that. So I'm saying, okay, I hold my verdict until I see such data. I want to see either materials or that I can analyze, or data that I can look into, and then I will tell you what I think about it. But just people telling me that such data or materials exist, is not enough. I need to see it. Now, of course, the US government may hold it classified, because some of the data was collected by classified instruments, and perhaps they are not sure whether it was human-made or not. But my point is, I will hold my judgment until I see it. I don't doubt that it exists. I'm not saying that Elizondo is lying. I think he's very sincere. I think Grush is sincere, but I haven't seen the data.
All right, I'm going to say you should be one of the first people to be let in from outside the government to look at these crash retrievals. Someone like you is exactly the kind of person that should be,
Thank you. Thank you. I mean, I'm just curious, and the difference between me and other scientists is that I don't know if they're curious or not, but they are showing a stand that is opposed to looking further into this. They say, oh, it's nothing. They ridicule it. And that's not the way that the scientists should operate, in my view. I mean, we should all be curious, especially about a question that is of so much interest to the public. The public pays taxes to fund science, and we have an obligation as scientists to attend to the public's interest. And when the government says we see things we don't understand, that's a serious matter. Because if it's not from outside of Earth, it means that the intelligence is not identifying objects that other adversarial nations are producing. And, that's something that everyone should be worried about.
Well, it's not just objects. Grush says we have bodies of beings.
Yes.
So wouldn't you love to see some of those, right?
Oh, yeah, definitely. I can easily, by the way, if I have just a gram of material, irrespective of whether it's a craft or a body, if someone gives me a gram of material, I can tell you right away whether it's from the solar system or from outside, because in our laboratory, we can analyze the isotopes and date the material, and we know the age of the solar system, 4.6 billion years. And if we find the material from another star, it will have a different age. That's another, even without studying the composition, just the age of the material, will tell us. And it's very unlikely that the material will have exactly the age of the Earth. And everything that comes from Earth, it doesn't matter whether it's artificially produced or everything has the same age of the solar system.
Right. But the material that Hal Portoff got from Linda Moulton Howe about the bismuth, magnesium, zinc, layers of material.
Okay. Yeah, but I don't know exactly where it came from, and I haven't seen it.
All right. Well, let's see. Maybe Linda can send you a little piece of her material she still has and see if you can analyze it. The other thing is, you're saying you're searching the skies for objects and you've seen nothing, because I've been out with night vision goggles and I saw an object in the sky that looked triangular. Its shape was pointed up. And as I was looking at it, it shifted to pointing down. Well, I'm not saying that's a UFO, but it's something, right?
Yeah, no, I'm not saying we don't see any. We saw 500,000 objects with our observatory.
Yeah.
And the point is that, the fundamental question, there is a lot of crap in the sky. There are drones, there are balloons, there are airplanes. And it's very easy to get fooled by, I can give you an example. I received an email a few months ago from a photographer that photographed a wedding. And he said, I don't want to release those photos because they are private and so forth. So I will sign you on an NDA, a non-disclosure agreement. I said, look, if you want me to look into this, I'm not signing an NDA. Just send me the photo and we'll look at it. Anyway, so eventually he sent the photo. We examined it with members of the Galileo project, and we concluded that it's a napkin flying behind the bride. So it's very easy to get fooled because it was only in one picture that he sent, and it did look triangular, but it looked, upon further examination, it did look like a napkin flying in the wind. Now, the thing to keep in mind is there are optical effects, that depending on the instrument you're using, sometimes things look weird because of the optics. And there are things in the sky that are, quite surprising because they are rare. So, we are basically looking in the sky all the time and training our machine learning models on things that are familiar. And we're simply asking, is there anything that is not familiar? And that means both in terms of its image and in the way that it moves across the sky, the trajectory. So,
and have you found anything that seems like you can identify, unidentified?
Yeah. No, so we found 500,000 objects, and most of them are things that we can identify, but some of them are things that we don't identify. And it's just the beginning. I'm saying, but this is the kind of systematic study that needs to be done, and we will continue with 2 additional observatories doing exactly that.
Right.
But if the U.S. government has data, then they can save us time,
Well, Chris Mellon and Lou Elizondo, they're part of the Galileo project. They've seen, I'm sure Elizondo has seen things. He's not talking about it because he has an NDA.
Right, exactly. So they are signed, both of them are signed to secrecy. They can't really tell some things, and they cannot share the actual data. And that's the problem. So it's really, we should see what happens in Congress in a month. I don't know. I really hope. There are 2 possibilities. Either the government is hiding something, and they would do that even if they don't understand what it means. They would just do it.
Especially if they don't understand what it means.
So my advice to them
what's the other thing? There's 2 possibilities. One, the government's hiding, and then the other possibility is what?
The other possibility is that these are human-made technologies that that we are not aware of, simply because we haven't developed them, and that would be of concern to the So it's quite possible the government classifies it because they are still suspicious that maybe this is produced by some humans. But if not, if they cleared that possibility. Because they found in crash sites things that do not look like humans, things like that. If they are sure that it's not human-made, they should definitely share it with scientists. I very much hope they will do so.
Well, do you think it's just, let's say the government is hiding things. It's not so much about aliens, from what I've read, and Elizondo sort of mentions it. They're taking some of this technology, selling it to industry, and it seems like that's happening. Or no, you don't buy it.
Okay, so here is the scenario that I would find likely. I don't
Okay.
think that these technologies are being used right now, because we would see them in the battlefield. Okay. So the way I think of this is more like something that the people that have the materials or the data, they simply do not understand. Now, they don't have, the best scientists in the world. They, for example, some corporations, they are looking into it, they can't really figure it out. So they are getting funded by the Department of Defense. And it's just like the relationship between a client and a psychiatrist. When you have a therapist, a good therapist would not solve all your problems, because then you will stop paying that person. So they might be in a situation like that, where these corporations are not solving or reaching any conclusion, so they get paid for many years by the government, and it's not a healthy situation. I mean, it would be much better if these materials or data would be analyzed by the brightest scientists in the world. You see, that's the way for us to make progress.
Well, you know Gary Nolan. Gary Nolan says he has material that seems to be off plan. Have you met Nolan?
Yeah, of course, I know him very well, but it's the circumstances under which this material was retrieved is somewhat foggy. It's not entirely clear. I heard him speak about it, but so he got the material from someone who noticed something, and that's not well documented exactly. It's not like the meteor that I'm talking about, which the data is public. The US government satellites measured the speed of this object before it exploded as a fireball, and then that it came from outside the solar system. In the other case, I don't know, maybe it was an adversarial nation doing some espionage and dropping some stuff.
Maybe Nolan could give you some of those pieces for you to analyze, because you said you would know.
I think he can do the analysis as well as I do. The question that I have about that material is, where did it come from? Do we have any evidence beyond any reasonable doubt that it came from outside the solar system or outside of Earth? And I haven't seen that evidence. The material is unusual, and it came under some unusual circumstances, but they are sort of somewhat foggy, those circumstances.
Well, I'm going to petition that you get on the next, inside track to look at the bodies, look at the craft.
And, I would be delighted.
And people
I just want to find the truth. I mean, it makes no sense to just deny the possibility that we have neighbors, cosmic neighbors, because it's to our advantage to realize that we are not alone, because we will adapt to that. I mean, it will be a blow to our ego. But just think about the blow to our ego that came with the realization that we are not at the center of the universe. That eventually we recovered, and we built spacecraft that reach Mars, even though Mars does not orbit around the Earth. That was a blow to our ego. So I'm saying it's important for our future to know the reality that we live in, rather than argue that, we are alone or we haven't seen any evidence, and then we don't seek the evidence because of that prejudice.
I agree with you. That's why Elizondo wrote this book, Eminent. But the other thing I want to ask you is, they're reporting artificial light coming from other planets or other star systems. And then also one more thing, when the Hubble looks at distant star, what evidence of life, maybe the artificial life or some methane in the atmosphere, would you expect to find if there was life there?
So again, it so happens that I wrote the first paper on artificial lights from a planet. I wrote it with an undergraduate student, Eliza Tabor, about 7 years ago. And we looked at the Proxima Centauri and concluded that, it would be quite challenging for the Webb telescope to detect it. But in principle, if there is enough light, we could see artificial light. Of course, within the solar system, finding artificial light, that's another paper that I wrote in 2012, 12 years ago, There we concluded that it is doable, and in fact we should search for artificial lights within the solar system, because you can tell the difference with existing data between an object that just reflects sunlight and an object that emits its own light. And the way to tell is that if it's illuminated by the sun, it actually gets fainter much faster as it recedes away from us.
And have you found anything? Have we found any artificial evidence at light of
Well, let me, I will mention an anecdote. So there was a famous astronomer, Mike Brown from Caltech, that discovered many of the objects in the Kuiper belt. And I asked him, I said, look, you are finding all these objects far away from the sun. Did you check whether any of them makes its own light rather than reflecting sunlight? And he said, why should I check? It's obvious that it must be just a reflection of sunlight. So this just shows you how most scientists operate. They never deviate from the beaten path. They already assume what they want to find in many cases, and
that's why you're so unique and so open-minded. We need people like you out there asking the questions. Even Neil deGrasse Tyson, when he talked about the Tic Tac, he said, "Oh, it was probably an artifact of the radar," and the pilots saw the object themselves. It was not an artifact.
One comment I should make is that there are many science popularizers that are not really practicing science. They pretend to be the defenders of science, but what they are doing is actually anti-science. Because if you are, if science is dear to your heart, you should work on it, seek the evidence, and not express opinions. And those are behaving just like commentators, that are telling the players in the field how to pass the ball. Who are they to tell? And they always have an opinion, but they're not really doing science. So I wouldn't put much stake at what they're saying.
Okay, that's something Bud Hopkins, I don't know if you know who he was. He investigated alien abductions. That's a whole other thing. But he said the job of science is to explain the uninvestigated instead of to the job of science is to investigate the unexplained instead of explaining the uninvestigated.
Exactly.
And that's so. What other signs of life that would a telescope like the Hubble look for on a distant planet?
So if we are looking obviously for primitive life, microbes, then it may be the composition of the atmosphere, but it's not very conclusive. For technological, the composition, molecules like oxygen or methane that are indicative of life. But a much more definitive proof of life would be to find technological signatures like city lights or artificial lights, or for example, industrial pollution in the atmosphere, molecules that are not produced by nature but produced by industries like the CFCs that we have in our atmosphere. Or to find a signal, that carries information that a natural system cannot convey. That's what the traditional SETI community was looking for. They haven't found any radio signal of that nature. Then what I try to bring to the table is the search for objects near Earth, which I think is more promising, because even if the sender is dead, we could still find them.
Well, talk about what would change for you and everyone else if we found microbes on Mars or life somewhere. How does it change the history of who we are as human beings and the nature?
Well, it's quite possible that life migrated between Mars and Earth, that we are all Martians, because rocks could have carried their life and arrived from Mars to Earth. Frankly, if we find life, of course, the question is it the same as on Earth? And if it's the same, it's possible the two planets shared it. And finding microbes is not as exciting, as far as I'm concerned, compared to finding intelligence beyond Earth, because from an intelligent civilization, you can learn, and it gives a new meaning to your existence. Whereas it's just like finding a partner in your own private life. It makes a whole different life for you in the future. And finding microbes will not have that impact. I mean, it would say that life is not rare, but I would doubt that we are unique and special. And we're probably in the middle of our class, kind of civilizations. And what I'm looking for is a smarter kid on our block, someone that was much more successful, because that will be shock therapy to our civilization, to realize that we can do better,
And we need some shock therapy because the planet is in help. So I think it comes down to the idea is, are we alone in a dead universe, or is life an emergent property of creation itself? That's my theory, that life is everywhere, and consciousness is not an evolution. It's the source of all things. But then we get into some spiritual discussions. But
there is a lot that we don't know, and I would say spirituality and the frontiers of science share one thing that in common, which is the quest for the unknown, and I think they can benefit from each other.
Yes. Well, this is what Einstein said. I'm sure Einstein said the spirituality and science are not disconnected. There is a connection. But those are the three big questions. They call it the three unknowns. How did the universe begin? How did life begin? And how did intelligent life begin? So any comments about your theories about that? And then I know you have to go soon. Yes.
I think intelligence in my vocabulary is measured by the ability to reproduce the reality that you're born into. So, we started in the jungle, and then we moved into cities when we developed technologies. And of course, the lifestyle that the city can give us has a much better quality. And that's why we are not on trees right now, so that's one step. But the next step would be to leave the Earth and go into space, because there could be an existential catastrophe on Earth that risks all of us. And if you ask what is the most intelligent species that I can imagine, it's a species that understands how the Big Bang happened. Right now, we don't understand what happened before the Big Bang, because Einstein's theory of gravity breaks down at that point when the density of matter was infinite. But if we have a theory that unifies quantum mechanics and gravity, we could have figured out the recipe for making our universe. And then you can imagine quantum gravity scientists creating those conditions in the laboratory. And to me, that is the biggest accomplishment, because it's the job requirement. If you were to apply to the job of God, the requirement would be you should be able to create a universe. So in principle, a very advanced scientist might be able to fulfill that requirement. And that's, so I'm really interested in intelligence beyond Earth, because, there is a lot of room for improvement for what we find on Earth. And if you look at the news every day, it's not uplifting enough. And, last week I had a podcast with Sean Ryan, and it was at the time it was the number one on Spotify, and I had more views than an interview that Kamala Harris had at exactly the same time. And so some people told me it's a reflection of the fact that the public finds science much more uplifting compared to politics. And I think science is better than politics.
I think so, because science gives us a possibility of the future, and politics, is just the past. But one more question. Where does all the water come from on Earth? Obviously, Mars had water because there's evidence of rivers and oceans maybe there. So where's water come from?
So water actually existed in the solar system to start with. It exists in the interstellar medium. So the cloud that made the solar system had water in it. And then it froze in comets, in the outer part of the solar system that is far from the sun. Water condensed on bodies, the rocky bodies. Outside of the orbit of Jupiter, it's very cold in the solar system because it's so far from the sun that water freezes. And so water accumulated on the on the surface of rocks, and these are called comets, and we see them because when they come close to the sun, the water evaporates together with dust, and we see a cometary tail. That's the origin of comets. But there was a period in time in the early history of Earth where the Earth was bombarded with such comets, and the popular idea is that was how water was delivered to Earth. So it came with comets that carried the water in them. And the same was true for Mars. Mars was not very far from Earth, but then Mars lost its liquid water because liquid water requires an atmosphere, and Mars lost its atmosphere. It's a tenth of the mass of the Earth, so surface gravity was not high enough to retain the atmosphere. And 2 billion years ago, it lost the atmosphere. But the early Mars was very similar to the early Earth. It had rivers, lakes, oceans. We see the evidence for that.
Right. Well, are you okay? When you're invited into the inside government and look at the bodies and the craft, are you ready to reevaluate everything you thought you knew about science?
Of course.
Isn't that exciting? You know,
it is exciting if something that can show me a different point of view exists, so until I see it, I will not know if it exists. It's just like, I have a lot of friends that were hoping to find a partner that is exceptional, and they were waiting and it never showed up, so they ended up compromising. So I don't want to end up compromising. I really hope that there is such evidence, and if it exists, I'll be delighted.
All right. Well, I hope they invite you I hope they show you this, because we need people like you to say, wait, what's going on here? The history of that we thought was now is a myth, so you're here to create a new understanding and a new science. This is, they're not filling up their gas tank to get here, these craft. There's another form of propulsion. So
I very much look forward, and I hope that in the coming years we will know much more.
I'm very excited. I hope they invite you in. I would vote for you to be part of that.
Thank you.
Panel, because I think it's time the government roll out the bodies and the craft and ask the world population, the scientists, and to say, okay, what do we have here? How does this work? And how can we use it to benefit humankind?
I agree. I completely agree.
All right. Well, keep up the good work, Avi. Thank you for everything you do. And what's coming up for you? Anything you're going to be speaking
There
about?
are a lot of things coming up. A few of them I cannot speak about, but you will hear about them.
All right.
So the things that I mentioned are the new expedition. We need $6.5 million to go to the Pacific Ocean again. And, I hope there will be a funder for that expedition.
I forgive me, but I think you're wasting your time. All you have to do is go to Washington and say, "Okay, show me the."
That I'm planning to do next month. Yes.
All right, great. Okay, you're going to be in Washington for the hearings on November 13th.
Yeah, but it's not confirmed. That they will have that because it's immediately after the election. So let's see what happens. Yeah.
But you're not speaking at that. Are you speaking at the?
I don't know as of yet.
All right, good. I hope they do get you to speak and, talk to your friend Lou Elizondo and Chris Mellon and Gary Nolan. David Grush, they could show, if you sworn for an NDA, would you take it and say you can't?
Yeah, well, if there is credible evidence, I think it's worth seeing it no matter what. But let's not hypothesize. If they ask me, I will think about it, and it's possible that I would like to see it under any constraints, just to help them figure it out. So the idea would be, even if I'm not allowed to tell other people, I will help them figure it out.
Right. Well, thank you for your honesty and your work and open-mindedness, and wait for the universe is about to shift.
Thank you.
It's Awakening of Humanity. That's the name of this conference, and thanks for being part of it. Really appreciate you. Thank you.